Hey everyone, welcome back to another video on kinematics. This will be the last video for a while. Maybe I could include a video more about the questions. So the last thing remaining in the syllabus is to design an experiment to determine acceleration due to gravity. Now there will be different variants of this experiment. This is not the only way to determine acceleration due to gravity. You can use pendulums also. You can use mass hanging from a spring, bobbing. That means both of these are an example of simple harmonic motion. Those of you who are also studying A2 will be able to understand this better. Over here we have used two light gates, but instead of two light gates, you could use a trap door to trigger and de-trigger the timer also. But this one, we are already familiar with the experimental process, but still we need to be able to write this carefully also. So let's start writing about it. So first things first, we need to know what the objective of this experiment is. We already know, but let's learn how to articulate our words. So the objective of this experiment is to determine the acceleration due to gravity by measuring the time it takes for a ball to fall between two light gates. Right. Now, the setup and the equipment requires basically. So actually the equipment that we require for this version of the experiment, you will need a retort stand. You will need an electromagnet. And you will also need some power supply, DC power supply, to power that electromagnet. You will need a switch and cables, switch, switch, cables, etc. Then you need two light gates plus data logger. What else do we need? Oh yes, we need a ruler. We need a ruler. Yes, we do need a ball, a small steel ball. Right. Okay. So let's. Oh, sorry. Okay. Now the methodology or method. So first things first, we need to assemble the apparatus. as shown in the diagram. Suspend the steel ball using the electromagnet powered by a power supply. Then what do we need? We need measure the distance or height between the two light gates using a meter rule. Farther they are, the better, but otherwise that's not quite big deal. And connect the light gates to the data logger. Right, okay. So turn off the switch or to power off the electromagnet, allowing the ball to fall. Through the light gates. Okay, next thing, record the time taken to fall between the light gates from the data logger, and repeat the step and repeat the experiment two more times, recording the times. Now we need to change the height also. Change the height. Actually, we should have given them numbers. You can give them numbers instead of bullet points. That would have been better. So 1, 2, 3, 4, 5, 6. Change the height between the light gates and repeat steps 1 to 5 for 5 more different heights. Now, we need to be able to record this data also. So, record all the data in the following table. So we don't need to draw up all the table, we just need to know uh, how the data would actually look like. So the main things are the distance. Actually, first I'm going to write it. So let's call it height, meters, because for every height we are performing the trial three times. So T1 seconds, T2 seconds, T3 seconds, and the average time, actually let's put a bar over that, for all of these trials. Are we missing anything? Yes, yes. One more thing. You have to think a little bit forward. Since initial velocity would be zero, we would have half a t squared. So you will actually need a time squared property also. So square of these values. Now we can basically put table headers. So these are the table headers that we will need. So for every height, you're recording this for three times and finding the average and then squaring that average. Now what we need to do over here, plot these values, plot, so, wait. Sorry, yes, plot a graph with distance h on y-axis and time squared, and the square of time basically, average time, t bar squared per second squared on x-axis. So we need to draw a line of best fit between the values. Now, we need to decide what the y-intercept and the gradient would tell us. Since we know, we are familiar with this, that, in this case, we have h is equal to half a t squared. We know that this is going to be the gradient and this is the x and this is the y. So the gradient of the graph, we just need this, is equal to half a. So therefore acceleration would be 2 times by gradient. So where acceleration due to gravity, you could have written this as g also, where a, if let's keep it as a, where a is acceleration due to gravity. Now, final note, the y-intercept had to be 0. So final, if a line, if the straight line passes through origin. The relationship is valid. The relationship between height and t squared. So height is proportional to t squared. So it should have, or it should have a line of best fit. Sorry, it should be a straight line passing through. Actually, we can draw that gently. So how this would look like is that you would have a line of best fit with some values scattered like this. So this would be your height per meter and this would be your t squared per second squared. Right, and that's the experiment. All right, so this method of designing an experiment would be very familiar if you are already doing paper 5 also. So we utilize a similar methodology over here. Although in that case we have an hypothesis also. We we are given the variables in that case also. Yeah, so that's it. All right. So hopefully we will see each other in the next video. Bye bye.